Good morning, everyone, and welcome back to another episode of the Aquarium Online Academy. My name is Ty, and I work here at the Aquarium of the Pacific here in Long Beach, California. And I'm also joined by my friend Sergio here in the studio today, who's going to be working all the magic that you see behind me here. Now, what we're going to do today is we're going to explore a very special habitat called the tide pool. And along our journey today, if you would like, we would love to hear from you. So I'm going to have my friend Sergio put up a number and email up on screen, and you're welcome to use this if you would like to share any observations that you have, or if you have any questions about any of the animals that we're going to learn about today, feel free. You can text us at 562-286-1838. And if you text us during the program, we'll be able to answer your questions live right here. Or if you're watching this afterwards, or if it's just easier too, you can use the email down below at live@lbaop.org. So even if you're watching this afterwards, you can still ask your questions, and we'll have somebody who's checking that email who'll be able to get back to you as soon as we can. All right, my friends. So what we're going to do here today as scientists together, and it is true that you watching here today, you are a scientist, because what it means to be a scientist is we're going to make some observations, which means we're going to explore and look at the world around us. In this case, we're going to look at some cool pictures and videos that we have for you today. And then we're going to share the things that we notice. And I'd love for you to share along with us today by using the information below if you'd like. And then hopefully by the end, we're going to share some ideas and learn a whole lot about some really cool animals. So the habitat that we're going to explore today are what we call a tide pool. Now, tide pools are very special habitats because it's sort of like where the land meets the ocean in a lot of these places. Now, in these areas, and I'll see if my friend Sergio can find us a picture where you can sort of see a little bit up close about how these areas look, but it's where sort of the rocky coastline meets the ocean. And so because of this, it's a very dynamic, a very changing habitat all the time. Now, oftentimes you'll find, even behind us here in this video, you can see that down below we're seeing some animals down here in the water, but actually, if you look close, there are some things that live up here on the rocks. Some marine animals that right now, at least, are out of the water. But how could that be? Well, the animals that live in the tide pools have to be very, very tough because, like I said, it's a habitat that is changing all the time. So what we're going to do today is I'm going to actually head over to my camera, and we're going to talk about how the tides work. So in these tide pools, you can see that, like I said, normally they're pretty rocky, but since that's right where the land meets the ocean, if you have ever been down to a beach before, you probably know that there's waves that are coming up onto the shore all day long. And in these areas where that happens, as the tides change, sometimes you'll get water that will fill these rocky areas and create the little pools, which is what we call tide pools. Now, maybe you've heard of the tides before, but maybe you're unsure about, well, what exactly that means. Now, I'm going to go over to my camera, and I'm going to do a little drawing so we can sort of see what that looks like for tides and what that means as we say high tide versus low tide. Well, I'll draw, let's pretend that this line is sort of like my rocky coastline. Actually, let's make it a little bit just so we can sort of see. So let's pretend we're going down to the beach, right? And up here is where maybe I park my car up on top here, and I walk my way down to the water on the beach. Well, the tides are going to be controlled by the moon and the sun, mostly the moon. And so depending on where the moon and the sun are around our planet, they will actually pull, the gravity will pull on the water and make it and get what we call the high tides and the low tides. In different parts of the world too, high tides and low tides will look different. Here in Southern California, we get 2 high tides and 2 low tides every single day. And so because of that, the habitat will look very different just based on what time of day you happen to go, on what time, or what the tides look like at the time you're at the beach. And so when we call high tide, what you might find is that the water will be will be high, right? That's our high tide. Actually, let's make it even a little bit higher so we can sort of see the difference. So if I had my water way up here, right? And then again, this is sort of our land up here. You can see that all these rocks that would be down below here, they're all covered, right? Because this is our high tide. But if as the day goes on and the tides start to change, you'll actually start to see that water sort of dip down. And because of that, your water might end up much lower. If it starts to drop, we might have what we call mid-tide, as it's sort of in the process of changing. And then at some point, you might have the water that is the low tide, right? And now, since the water was in the high tide, it was covering all these areas. As the water gets pulled out, right, so it lowers down to low tide, what we get left as the water pulls away are some of these pools, right? And so here is what we would find would be a pool that is left over as the water has dropped down. Now, we have animals that live all the way along this line, right? So if I draw our high tide line back up, we have animals that live way down at the bottom, so that ones that like to be in the water all the time. But there are some animals that are strong enough and have special adaptations or things to help them survive that help them to live up here. But remember, if my water is going down every single day, they need to find ways to survive even if they're going to be out of water for a little bit. And so the tide pools, they are a pretty tough place to live because, as you can imagine, if the water is changing this much every day, there's lots of challenges that these animals are going to face. So let's see if we can take a look. Maybe we can look at that video again or just another video of a tide pool so we can get an idea about what some of the challenges might be that these animals are going to face when they're living in this ever-changing habitat. So if you're an animal that is in this place, can you think of any challenges that you might face if the water is changing every day? And maybe if you've even been to the beach before, sometimes that sun can be coming down really strong, right? And so there are lots of challenges that these animals face. Now, if you get stuck up on top of a rock and the water goes down, you have to find ways to make sure that you don't get too hot, you don't dry out, right? Because you're an animal that needs to be in the water. And so we'll talk about some animals that have special ways to survive that. But also, look here. The water is constantly going to be moving, right? And the currents can be pretty strong in the ocean, right? And so as these tides are changing, there's a lot of movement going on. And so if you're a tiny little animal here in the tide pool, you need to make sure you have ways to not get swept away, right? You want to make sure that you're not going to get taken anywhere that you don't want to be. And so that's what we're going to sort of focus on today, is learning about how some of these animals deal with that constant movement of the water. What are some special ways that they can make sure that they stay in place and that they're tough enough to withstand these tough ocean currents and the tough tides that are changing every single day? So I'm going to have my friend Sergio take us to our very first animal that we're going to explore. It's probably one that, well, it might be familiar to you. They're famous for their special shape that they have. And we're going to see if we can take a close look at our first animal and explore the ways that it survives in the tide pools. We're going to look at the sea star. So as my friend Sergio finds us a picture of a sea star, I want us to think about what kind of things you notice on their body. What would be some things that they might have in order to help them to survive? So let's see if we can take a look here. These types of stars are called bat stars. And here in Southern California, these are one of the species that you might be able to find if you go to our tide pools. Now, all of these stars, well, you can see here, they're sort of stuck up against a rock. But I wonder how they're doing that. Now, sea stars are very special. They're really cool for a couple different reasons. One of them is, look how colorful they are, too. Maybe you notice just how many different colors they come in. And different kinds of sea stars come in all different kinds of colors. Almost every color you can imagine, there is a sea star in that color. Some that have many, many colors, too, at the same time. So they're very pretty, but they also have some very cool adaptations in order to survive. So I wonder, how would a sea star in the tide pool be able to survive those tough movement of the waves? I wonder what they have in order to do that. Well, on this top side, if you were to give them a feel, they do have a pretty tough skin, tough plates on their outside that help them to stay tough, sort of like having armor. But the real trick for staying safe in the tide pools and making sure you don't get swept away has to do with what's on their underside. So let's see if my friend Sergio can find us a picture or a video of the underside of a sea star, and let's see what you notice now. Does anything stand out to you here on the underside of a sea star? So what you're looking at now is one of our windows of our exhibit, and one of these sea stars has stuck itself onto the window. So they're very good at sticking. Sticking is the key. But do you see anything on them that would help them to do that stick? Take a look here along their arms. Now, most sea stars will have 5 arms, right? As you can see here, this one has 5 of these arms. 1, 2, 3, 4, and 5. But some sea stars have even more. In fact, I think Sergio can show us a picture of a really cool star called a sunflower star that has even more arms, and see if there's anything similar that you notice between this and the one before, though. What is along all of these arms? Oh, it looks like we got a question from Abraham. Thanks for tuning in. And the question was how many different types of sea stars there are. That is a great question. Now, I'm not sure what the exact number is, but there are, I want to say at least, I know it's in the hundreds, but it might even be over 1,000. Maybe I'll have my friend Sergio see if he can find us a for sure answer, but I know there's at least hundreds of different kinds. Here at the aquarium, we have like 20 or 30 different kinds. Now, some, like the bat star you saw, even though they're the same species, they come in all different colors. This one is a very special star because you can see, do you notice anything special about this one compared to the bat star? Quite a bit different, right? They can have up to 24 of these arms all around them. And so with so many arms, do you see that they have so many of these other things here? Oh, it looks like there's even closer to 2,000 species, which is awesome. Tons of different sea stars to find in our oceans, and probably more that we haven't even discovered yet, which is really cool, because they're found in almost every ocean habitat. In this case, we're talking about some that you can find here in those tide pools. Now, let's take a look here at the bottom, because on the underside of the sea stars, you'll see these are what we call tube feet. So, feet, right? What do our feet do? Well, they help us to move around, right? We have our feet. For sea stars, they have thousands of these tube feet. Now, they get that name tube feet because if you look closely, they're shaped like little tubes. Look here. And so on all of these little tube feet, on the very end, there's almost like a little suction cup. And so, sea stars, when you have tons of these little suction cups, they can form a very, very strong stick onto the rock, which is really cool. Now, even though they're really, really strong and sticky, can you see how fast a sea star moves here? It's not very quick. So even though sea stars are not the fastest animals in the tide pools, those sticky tube feet help them to make sure that they can stay stuck onto that rock and make sure the waves can't sweep them away. Now, those tube feet are also going to be helpful for finding or for opening their food. And so they actually love to eat something called mussels. In fact, maybe, Sergio, we can jump a bit to our mussels now, since we're talking about what the sea stars like to eat. So if you want to go over to our camera real quick, I'll show you some mussel shells, and then I believe we have some pictures that we can show you as well. So one of the animals that sea stars love to eat are things called mussels. Now, if you at home are a fan of eating seafood yourself, you may be familiar with mussels too, because humans like to eat these too. But mussels are animals that you can also find in the tide pool. And what is special about them is they have 2 shells. Now, unfortunately, the shells that I have here are not from the same mussel, so you can see they're not a perfect match, but this should hopefully show you sort of how their body is laid out. But mussels are really cool because inside of these 2 shells, the animal will live, the soft body of a mussel. But when they're in the tide pools, they have their shells that are stuck down here, they close up, and so if a mussel ever feels like it's in danger, or when the water goes down, when it's low tide, they can completely close themselves up and keep themselves safe. And so when you see these mussels out in the tide pools, like you can see here, there's actually a couple different animals in here, but we're looking at the mussels, which are these blue ones. Well, bluish, orangish, there's a whole bunch of colors. But these here, you can see that shape of their mussel shells. So they have 2 shells that they can use to close themselves in, because look in this picture. They're not underwater right now. Because as the water goes down and like in the tides, like we were talking about earlier, these animals get left exposed out in the sun. But the mussel's special ability to close themselves in and keep them tight, can prevent them from overheating. It keeps the water inside. And so all they have to do now is wait. They'll wait for that water because remember, the tides are going to come back up eventually. And so as the tides come back up, these mussels can actually then open up their shells to start feeding. Now, this is where the sea star's tube feet come in handy, though. These mussels are very good. When they want to lock themselves in, they can do it, and they're pretty strong. But the sea stars are even stronger. So what they'll actually do is the sea star will crawl around and find itself a mussel. The mussel will sense danger and close up. But the sea star can actually use its sticky feet to go over the shell of a mussel and actually pull it open. Now, the next part might sound a little gross, but it is how sea stars are able to eat this food. Because then what they do, once they've pulled open that shell, is the stomach of a sea star will actually come out of their body, into the shell, like you see here, eat the mussel, and then pull its stomach back into its body, leaving nothing but the empty shell like you saw before. I know. It sounds a little gross, but that stomach that you just saw in the middle there is actually how they do it. Their stomach could come out of their body, eat their food, and bring it back in. Kind of gross, but pretty cool. Oh, awesome. We got another question, which is what are the sea star's closest relatives? Great question. And in fact, we can show you some. So, sea stars are part of a group called the echinoderms. Kind of a weird word, but echinoderms means spiny skin. And so it's sort of known for having that sort of spiny, scaly skin. Now, bat stars are actually a little bit smooth, but lots of other sea stars will actually have pretty big spines on their body. Now, those spiny skin is even easier to spot in their cousins, the sea urchin. So let me see if Sergio can find us a picture of a sea urchin. Because sea urchins are relatives to, oh, here's another star. So these white spots that you can see on the ochre star, which is this one, those are actually little spines. And so if you were to feel this animal, they do feel pretty tough, almost like a bumpy rock. But you'll see the spiny skin in their cousins, like the sea urchin here. So they're related to sea urchins. So sea urchins have spines that cover their entire body. Some have huge, huge spines. But also, those tube feet that we talked about, the sticky suction cups, those are also shared by all of its relatives. And so sea urchins actually have tube feet all the way around their body. Kind of hard to see in this picture, but they'll have tube feet down at the bottom and all the way around their body that use for the same purpose, for sticking themselves onto their surfaces. Now, another one of their relatives is the sea cucumber. Maybe we'll see if Sergio can find us a picture of a sea cucumber. Now, sea cucumbers are really cool. They're sort of like the cleaners of the ocean. They sort of crawl around, looking for food along the bottom, and making sure all those nutrients get recycled again. Now, the sea cucumber, take a look here. Do you see the spiny skin again? Definitely. Now, in the sea cucumbers, though, for a lot of them, it's kind of a trick. A lot of sea cucumbers look very spiny, but they're often not that tough. It's usually pretty squishy, but it's sort of a trick to trick things into showing that they're spiny. But look down here at the bottom. See it again? Tube feet once again. And so if you want to see what kind of animals are related to sea stars, the spiny skin and the tube feet are two things that you can look for. And so sea cucumbers are also cousins to the sea stars. Now, there are a couple more other kinds, like brittle stars and basket stars. There's other animals, too, that are related to them. But sea stars, sea cucumbers, and sea urchins are sort of like the big groups where you can find a whole bunch of different kinds. And it's really easy to spot those things that they share. Great question. So, ooh, great question. So we got a question about how do these animals see? Well, let's flip back to a sea star and take a close look. Well, I'll leave it to you first to maybe see if you can take a guess. Do you see any eyes on a sea star? Is it maybe in the middle? Is it over here? Is it one of these dots maybe? I know they have a ton of them, right? Are they those? Well, if you want to see how a sea star sees, you have to look towards the tip. The tip of each of these arms, right? And in fact, in this one, you can see that they're almost like sticking their little arms up at the end. Now, sea stars don't have eyes like we do, right? We have very good eyes to see the world around us. But sea stars do have what we would call something like eye spots. They're very simple eyes. And so on the tip of each of these arms, a sea star will have these eye spots that although they can't see images of the world around like we can, they're not that good, they are able to tell if it's light or it's dark. Now, to get a sense of what that's like, if you close your eyes right now, and then you sort of like move your hands in front of your eyes and out, right? Because I'm under bright light, so it especially works right now. But even though your eyes are closed, if you change the lighting around you, you can actually see a bit of a difference. And so even though they can't see the world as good as we can, they're able to use that sensor of light and dark to figure out sort of where they need to go. Should I be in a dark place to protect myself, right? Or if I am out in the high light of a sunny day during high tide, that probably means if I'm a sea star, I need to get moving down to somewhere where the water is, right? And so, although they don't have eyes like we do, they still have the ability, using those eye spots, to have a very simple sense of light and dark. Great question. Now, let's see if we can maybe introduce another animal of the day, because I want to introduce one that I don't think gets enough love. I think they're very, very cool. And their closest relative that we've talked about today is the mussel. So if you think back to the mussel, mussels have these two shells, right? In this case, they have two shells. But can you think of any other animals that have shells? Maybe even those in the tide pools. Now, one that you might think of is probably something like a snail. There are lots of snails that live in the tide pools. Maybe Sergio can show us a quick picture of a snail, and we can take a look at one that might live in the tide pool. But snails, there's a whole bunch of different kinds of marine snails. This one here is called a Kellett's whelk. But snails in the sea kind of look like, snails that you might find here on land too. Their sort of characteristics that they have are a very sticky foot down at the bottom, so they can stick. So that's how snails will deal with the changing water. They have a very sticky foot that they can use to attach themselves, and they sort of glide along a surface, right? Slide like a snail does. Now, also, you'll notice that they have this really big, in this case, big, but sometimes they'll usually all these snails will have a shell on their back. Can you think of any reason or how a shell would help a snail out in the ocean, or especially out in the tide pools? Well, as you can imagine, if your body is really soft, similar to how the mussel had a soft body that was protected by a shell, the snails also have a shell that protects their soft body too. And so as the waves are crashing on them, or even if there's predators that are lurking, the snails can retreat into their very tough shell and use that to protect themselves. Now, I want to introduce a new animal to you that's related to the snails and the mussels, but they're a little bit lesser known, but in a lot of places, like here in Southern California, they're extremely common in the tide pools. So I'm going to have my friend Sergio switch us over to either a picture or also on my camera, I'm going to show you some stuff as well. But I'm going to introduce a new animal of the day today that I hope you will learn to love and appreciate. But we're going to introduce to you the chitin. Now, let's see. If we go over to my camera, I've actually brought some shells from a chitin, or a couple different shells from chitins. But what's special about these chitins, and normally they're pretty small. We'll zoom in here so you can see for sure. You can see all these are pretty tiny. But chitins are really cool because their shell is really special. Because instead of having one big shell like a snail, or instead of having, like we saw in the mussel, where they have two big shells, right, that close up, their shells actually come in plates. And so they'll have 8 of these plates that line up along their back and provide this really cool armor along their backside. So on the underside of these animals, now these are just the shells, so they're not here anymore, but on the underside of these of the shells would be where the soft body of the animal is, kind of like the body of the snail. Now, just like a snail too, they have an extremely, extremely strong foot on the bottom. And so these are some of the toughest animals in the tide pool because their sticky foot is so strong, they can resist getting pulled off by anything. And then these plates of armor that you can see here, here's a picture of some chitins that are out in the tide pool. They have these tough plates that protect their soft body underneath. Now, sometimes, like in this case, you can actually see their body along the outside. So that circle is actually the body of the chitin. But they do have a head region, kind of like a snail does too, right? So they have one way that they slide along, but their armor is so tough and their foot is so strong that they can sort of just whenever the waves are going down or the waves are crashing on them or the tide goes down, they're able to withstand all of these changes by just sort of anchoring down and staying tough, even though they're not very big. Some of these are really, really tiny. Now, chitons are also so cool because, well, why don't we go back to our camera really quick and I can sort of show you. These are just a couple different kinds, but what I think is so cool about these is they come in all sorts of really amazing colors on their shells. Oh, we got a great question if they change shells like hermit crabs. Great question. Now, earlier we looked at a snail, right? Like the Cowlitz, or in this case, the chiton who make shells. Now, something that's pretty interesting is the snails, or in this case, the chiton, or even the mussel, those types of animals build the shell. That's part of their body. So as they grow, they will build the shell themselves. Hermit crabs are actually kind of sneaky. Hermit crabs don't make a shell at all. What? But I see hermit crabs in the shells all the time. How do they get that then, right? Well, what they're actually using are the shells from dead snails, or sometimes other things too. But really, dead snails is the key. Because when a snail dies, the soft part of its body, like we looked at in that whelk picture earlier, the yellow part, the soft body will break down, but the shells will remain, and you'll just see an empty shell. And so if you see shells at the beach, if you go down there, all of those were actually made by a living animal at some point. Hermit crabs, they don't make the shell, but they're very good at finding them. And so they find these empty shells, and they make them their home. Hermit crabs have a very special part of their back that they can use to hold on to shells on their back. So since the hermit crab isn't making the shell, though, like a mussel or a snail, as they grow, the shell isn't part of their body. It's not growing with them. And so as they get bigger, they need to move out of that shell and find new ones. And that's why you see hermit crabs trading into bigger shells, right? Like here. As the crab gets bigger, it's going to need to find big shells on its back. For snails and mussels and chitons in this case, the shell is actually part of their body. So the shell grows with them. Pretty cool, right? Great question. So snails and mussels, all of those mollusks, they make the shells. Hermit crabs, they just find the empty ones, which is sneaky. All right, now let's go back to the chiton really quick because I do want to show you something pretty cool, a little surprise I've been waiting on because I wanted to show you, introduce this brand new animal today and show you just how cool these plates that they come in. Now these are even kind of a similar color, but you'll also find some that have really, really bright colors. Now all these that I've shown you so far are very small, right? I'll put my my finger here so you can see. Pretty tiny, but there's actually one chiton in the world, and you can actually find these in some parts of California. But there is one chiton that trumps all other chitons, and that is this one here. This is a very special chiton called a gumboot chiton. Now this one is just the shell plates in a box, but look at that, right? So here's one of the smaller ones we were looking at earlier, and look at this one. It's huge. So the gumboot chiton is the largest chiton in the world. They're gigantic. They kind of look like big, huge potatoes when they're living. It's pretty cool. But you can see this one was actually found in California too, all these shell plates. So the chiton, I hope you have found a new interest in these really, really cool mollusks because I think that they're so cool, especially all the different ways that their shells will look, their different plates. I think that they're just so cool, and maybe you thought they were cool too. And also, they are so tough, the way that they're able to survive in the tide pool. I think it's very impressive. So I'll have my friend Sergio bring us back to a tide pool, and we can wrap up all the things that we were able to learn today. Well, first, we learned what a tide pool was, right? Tide pools are where the land meets the ocean. They're those rocky areas, and as the tide rises and falls, the habitat can look completely different. At one point in the day, you might see nothing but water covering this whole area. But if you come back a few hours later, the water may have gone all the way down, and you see all these rocks exposed and all these little pools that we call the tide pools, right? Here are all those pools that are forming. Now, in these tough places to live, because you might deal with being out of water or deal with constant water movement, right? Because look at that. Those waves do not mess around. They can be pretty tough. We explored some of the ways that these animals deal with these challenges. So we talked about sea stars, as well as their cousins, the sea urchins and the sea cucumber. Now, do you remember what those animals had in order to survive out there? They have the spiny skin, that tough skin to protect themselves, but they have those tube feet. Those sticky suction cup feet that you find on all of those animals are key to making sure that they stick onto those rocks so they don't get swept away. And we also learned that they use those sticky feet to eat some of their food, like the mussels. Now, mussels are another animal we talked about today who are famous for their, well, there are lots of other animals that also have this, but mussels have the two shells that attach to each other. Now, something we didn't talk about is how they stay in place, because they actually make these special threads from their shell that actually sort of tie themselves onto a rock. But the two shells are a great way for the mussel to protect themselves when they're out of water, even though a sea star is tough enough usually to open that shell up and eat a snack. And then finally, we talked about some other mollusks too. We looked at a snail. Now, in our case, we looked at the whelk, who have a very sticky foot and a very strong cone-shaped shell. And we also learned that hermit crabs are not the ones making that shell. They're just stealing them once they find them washed up. They're very, very good at using those shells to make their home. And then also, we also introduced a new animal. Maybe it's a new animal to you, the chitin. Now, I think chitins are so cool because they're really great at surviving all of the challenges of the tide pools. Now, if you happen to be by a tide pool and want to go exploring them now, this is a great place to go. Now, you don't need a scuba tank to survive or to visit and explore a tide pool. You just need some good and maybe a towel in case you fall in, because that can happen too. It's a little bit slippery. Be careful out there. But when you're exploring the tide pools out there, you will find that there are lots and lots of life that call the tide pool home. And oftentimes, at first glance, well, you might not notice, but you'll probably find lots of those little chitins surviving out there and being the tough little armored critters that they are. All right, my friends, so I want to thank you so much. I'm actually going to have my friend Sergio throw up the number really quick one more time in case you have any texts you'd like to share as we wrap up, or you're also welcome to use the email down below if you'd like to send us an email after watching this. But I hope you had a great time exploring with me. I had a great time exploring with all of you scientists. I really enjoyed all of your questions today. And if you're still thinking of some, please feel free to use that text number or the email down below, and we'll be sure to get back to you and answer any and all of your questions. But thank you so much for joining us. We hope to see you again for another episode of Aquarium Online Academy. We will have a Spanish program here today at 10 o'clock with Sergio. So we'll hope to see you there or at another week for another episode of Aquarium Online Academy. Thank you so much, everyone, and have a wonderful day.